So now that we've learned about the NAND and the NOR function and how I told you they were functionally complete, we're now going to translate our SOP and POS forms of the equation to NAND, NAND, or NOR, NOR forms of the equation. And why do we want to do that? Well, like I said, what if we only had a toolbox of just NAND gates? Well, we can then create any sort of digital circuit out of solely NAND gates. It's that awesome. Or if we just had NOR gates, we could create any digital circuit out of solely NOR gates. And so once we learn these two forms, you get to add it to your repertoire of forms or models and be able to switch between any one of them. So it's very, very easy to go from SOP to NAND, NAND. And also very easy to go from POS to NOR, NOR. But to go between these two domains, as we've seen before, to go between SOP and POS, it's useful to use the truth table. You don't have to, but I think this is the easiest method. So let's first look at how to go from SOP to NAND, NAND. So here is an SOP equation. I'm not saying this is necessarily reduced or not. This is just an equation in the form of sum of products. Now to go to NAND, NAND, what we're going to do is take the complement of both sides twice. So when you take the complement of both sides twice, your left-hand side just becomes itself, because the complement of the complement is just back to being itself. Now this side of the equation, we want it to be in NAND, NAND form. So we want to keep these guys in an AND type looking thing. We just need to get rid of these ORs. So what we're going to do is we're going to use this complement bar to just translate these ORs into AND. So basically you're going to get the same exact thing with a bar over it, and you basically put a break in the bar to be able to transfer this OR to an AND. And then this upper bar remains. So now look at this. We have this is a NAND, a NAND C. This is a NAND. This is C not NAND D. And this is a NAND. And then the output of all of these guys is also NANDed. So you see, it was so easy. All you had to do was basically change these ORs to an AND and have these extra bars on top. Similarly, with the POS form. Let's put a POS equation here. All right, I have A or C ANDed with D or B not. So to go from POS to NOR, NOR, you take the complement of both sides. We want to keep this OR looking thing, but we want to change this AND to an OR. So this becomes F equals A NOR C, D NOR B not, with a big bar over, so they're all NORed. So look at that. Now we have a NOR, NOR form. All right, yeah, so it's very easy to go from SOP to NAND, NAND, or from POS to NOR, NOR. So what if we wanted to go from NOR, NOR to, how about SOP? Well, guess what? You're going to have to go from NOR, NOR to POS to the truth table to SOP. Now let's go ahead and do an example of that. So here's an example of going from NOR, NOR to SOP. Here's our equation in NOR, NOR. We're going to do A NOR B, NORed with B not NOR C. All right, so we can easily go to the POS form by just pretty much writing what we see, but taking away the bars. We've got a so we've got the POS. Now to enter this into the K-map, it's easiest to get an SOP form for F0. So we're going to get F0 by taking the complement of both sides. So we're going to demorganize the right-hand side and get A0 B0 or B C0. Now we can go ahead and put this in the K-map as zeros. So this is a 3-variable K-map. We've got our A0, B0, sorry, B0, erase. Here we go, B0, and this was C. So A0, B0, remember we're entering zeros because this is an equation for F0. A0, B0 goes here. B, C0, B, C0 goes here. And then we have our ones. So now that we have the K-map, we're going to circle ones to get SOP. And we can do these together and these together. So we're going to get F equals A B0 or B C. Cool.